morning. First of all, I would like to thank the organizers of the conference for inviting me, allowing me to present some of my research from my research group. I would like to also thank for allowing me to be given the opportunity to meet other faculty, students that are working in the fruit and vegetable post-harvest area, and I wish you the best of conference for the next 2 days. With this, what I'm going to do today is give an overview of some of the issues that are specific for the United States, but also for the entire globe right now, associated with fruits and vegetables. In the United States, in the past 5 years, so 5 years ago, fruit and vegetable safety was not even considered. The majority of foodborne illness outbreaks and illnesses associated with food were primarily meat. But within the last 5 years, fruits and vegetables have been identified as a major source of foodborne illnesses. And because of this, has become one of the United States' #1 research priorities for researchers. This graph represents the number of illnesses in the United States over a 10-year period, excluding meat. Meat is still responsible for 70% of all foodborne illness outbreaks in the United States. But within this group, you can see that 37% of all the other illnesses associated with foods is due to produce, fruits and vegetables. 5 years ago, this would have been 0. And it's because of this that it's become very important for consumers, but also from a regulatory or government standpoint. Specifically, what types of fruits and vegetables that are associated with the outbreaks? The majority of the outbreaks are due to leafy greens. This would be lettuce, spinach. They're responsible for the largest proportion, followed by melons and then tomatoes. These are very common produce, fruits and vegetables that are consumed in the United States and have been identified as being the source of foodborne illnesses. What I want to do is, why all of a sudden is there an increase? Is it because farming practices have changed? What has changed in the past 5 years? Because in 5 years we went from not having fruits and vegetables representing a food safety problem to now being a #1 priority in the United States. One of the largest contributing factors to the identification of produce as an important foodborne illness vector is because methodology has improved dramatically for fruits and vegetables. We have much more sophisticated and sensitive detection methods, PCR-based, antibody-based, nanotechnology, so detection has become much more sensitive, also much more rapid. In addition, in the United States, we have what is called PulseNet, and these are 5 isolated laboratories around the United States that are responsible for collecting all the information about reportable illnesses. These are then tracked, and they're tracked across the United States, so you can see very quickly when an outbreak begins. It leads to faster response to outbreaks so that less people ultimately get sick. What has also changed in the United States is that Americans have become healthier in terms of the way that they eat. Rather than just meat and potatoes, they're now eating much more fruits and vegetables. The USDA, the United States Department of Agriculture, for the past 25 years has been encouraging consumers to increase fruit and vegetable consumption through a program called Strive for 5, meaning having at least 5 portions of fruit and vegetable in the consumer's diet every day. Before, the traditional diet was meat and potatoes, very, very little fruits and vegetables. So in the past 10 years, dramatic increase in fruit and vegetable consumption, and this is starting off 10 years ago, 577 pounds per year. Now, we Americans eat over 700 pounds of vegetables. In just 10 years, we've increased our consumption by more than 200 pounds. Also, in the past 25 years, and even more in the last 10 years, the fruit and vegetable industry has become global. We now get cherries, we get green onions, we get all sorts of fruits and vegetables from all over the world. Whereas before, it was locally grown and locally consumed. So now with this wide distribution through technology, active developments in packaging systems, more efficient transportation, we now can have fresh produce that comes from Southeast Asia that arrives in the United States in less than 24 hours. One of the concerns when the outbreaks were increasing is that they were concerned that international or imported produce, so fruits and vegetables, are more risk for consumers than domestically produced. But what the FDA found, they did an investigation comparing imported and domestic production, and there was no difference between the isolation of pathogens from produce, whether it be from domestic or imported, which means that there's no higher risk with export or imported produce. In fact, production standards in import from the exporting countries are sometimes better than those that we have in the United States, because they recognize the importance of good agricultural practices and good manufacturing practices on the final impact of fruits and vegetables. In the United States, we have, it's very popular for organic produce. Organic meaning no chemical fertilizers or pesticides. However, it may be safer from a chemical standpoint, but from a microbiological standpoint, organic produce has a higher risk associated with it due to foodborne pathogens being transmitted through some of the compost, manure, or water that's used to produce these organic produce. One of the biggest problems associated with fruits and vegetables is that it's very complex. Consumers want to eat fruits and vegetables that is fresh. So the existing decontamination or treatments to make the produce safe destroy the quality of the produce. The other problem is that organic fruits and vegetables are grown in soil. They're grown in the environment. So it's natural to have contamination from soil. It's impossible to grow fruits and vegetables by excluding birds from flying overhead. It's very difficult, and you cannot produce fruits and vegetables in a sterile environment. So we have to accept that there are going to be certain introduction of contamination on fruits and vegetables. Fruits and vegetables are generally consumed raw because of texture. Nutritional quality is also improved with less processing. The other problem is that with fruits and vegetables, especially leafy greens like lettuce or spinach or cilantro or coriander, it's very difficult to clean the produce once you have contamination on the surface. With melons, you can use a brush to remove the soil and some of the contamination, but you can't use a brush or physical abrasion to remove the contamination on very delicate produce items. The other complicating factor is that plants are a living entity, and as soon as they have stress, in response to the stress, the stomata on the plant cells, they close. If there's been contamination during growing, you can have internalization of pathogens inside the stomata, which don't allow for your disinfection to actually inactivate the pathogens that might be contained inside the stomata now. So it's very, very complicated. The other fresh cut produce There's whole produce and then fresh cut. In the United States, we're eating more fruits and vegetables, but we become more lazy because we prefer already prepared. We open the bag, we empty the lettuce, and it's ready. No preparation for cutting or cleaning. There's been increase of more than 300% in fresh cut produce in the last 10 years. Very high increase. However, anytime you cut the produce, it allows for small amounts of sugars, carbohydrates, micronutrients that get leaked from the cells in the plant, and that can actually be a substrate for pathogens to grow on. Whereas on the whole produce that is not cut, the pathogens aren't able to grow. But as soon as you cut it, it allows for pathogen growth. So fresh cut produce represents a higher risk for potential of pathogen growth. Fruit and vegetable microbiology is also very, very different compared to milk, meat, or water. It's because fruits and vegetables have a very specialized microbiota, which means the microorganisms that are associated with fresh fruits and vegetables. Normally, in other foods, dairy, water, meat, they use coliforms or fecal coliforms as an indicator of fecal contamination. However, with fruits and vegetables, it cannot be used as a fecal contamination indicator. And this is because fruits and vegetables naturally have Klebsiella and Enterobacter and Citrobacter as part of the microbiota of fruits and vegetables. These naturally occur, they mean no indication of fecal contamination, but they show up as a positive in coliform and fecal coliform tests. So it gives a false positive for the potential of fecal contamination of fruits and vegetables. Rather, E. coli is actually a better indicator for fruits and vegetables to use as an indication of potential pathogens being on fruits and vegetables. The other complexing thing is that fruits and vegetables, because of the natural bacteria and yeast and molds that are contained on the surface, aerobic plate counts are a very poor indicator of quality for whole fruits and vegetables. For cut or processed fruits and vegetables, you can use aerobic plate counts as a quality indicator, but for whole fruits, it's not a very good indicator, simply because it's a living microorganism that has a specialized microbial ecosystem associated with it. In addition, fruits and vegetables, along with the microbiota, have a very complex, and this is very new research. They have found that enteropathogens, so E. coli, Salmonella, Shigella, they induce expression of general stress response genes. So RPOS and sigma B are genes that induce the expression of virulence, internalization, toxin genes, and as they pass through the human's gut or gastrointestinal system, the stress promoters upregulate the virulence determinants, and it causes enhanced acid resistance, and pathogens, the foodborne pathogens, become more virulent. In addition, epiphytic bacteria that are normally associated with fruits and vegetables have been found to have a commensal relationship, meaning that they benefit from each other with the foodborne pathogens. Examples are Salmonella enterica, which is the most common salmonella associated with foodborne illness, and Panthea agglomerans have a very close commensal relationship, and actually you have higher levels of salmonella being present when you have Panthea present. Similarly, Listeria papilla, it actually supports, it prolongs the survival of E. coli 0157 on fruits and vegetables. It's like it assists the pathogens in growing and in also surviving on fruits and vegetables. Acyl homoserine lactones are small molecules that you can find produced by other bacteria, even in some plants. They are actually, these upregulate these general stress response. It increases stress resistance, so it makes sensitivity to fluorine, to heat, to ultraviolet light. They have enhanced resistance, so they survive much longer just because of the lactones upregulating the stress response. You can also have increased virulence just because of these acyl homoserine lactones as well. So it's very complex, and all this research is just being evolved in the last 5 years. How do pathogens enter into the fruits and vegetables? It's not only on the farm, it can be in the transportation, it can also be in the packing house, it can also be in the home or at the grocery store. So there's many, many entry points. But one of the primary entry points is at the farm level. We have very often pathogens associated with fecal material, which is commonly used to supplement the soil as a nitrogen supplement. The pathogens can be transferred onto the plants either by aerosols, by insects, flies, even nematodes, amphibians. You can also have indirect contamination from human feces. The human feces workers. This is why now providing easy access to bathrooms for the workers in the field is very, very important. You can also have fungi, protozoa, nematodes. They actually have been found to colonize the foodborne pathogens, and when they go to the plant, they then cross-contaminate the plant. And it's not only on the surface contamination from the leaves or the stems, but the pathogens have also been found to be able to be infiltrated from the roots and become systemic throughout the plant. So it was prior to that, the root hyphae were thought to exclude the bacteria from possibly internalizing plant tissue, but that has been found to be not true. The most common sources of pathogens for fruits and vegetables: untreated manure added to compost, wildlife, birds, deer, wild pigs. In the United States, 2 years ago, we had a very large outbreak of spinach, and it was actually found because wild pigs were coming into the spinach field, and the feces contaminated the spinach, and it destroyed the spinach industry in the United States. Rodents, these are mice or rats, reptiles, more in the tropical areas of the United States. Frogs, lizards, they always carry salmonella, and they potentially cross-contaminate the produce that they sit on. Also, domesticated animals, cattle, sheep, goats, pigs, chickens, also, they provide cross-contamination. They provide the fecal material where the pathogens originate. They can be cross-contaminated through aerosols. Even if you have a heavy rain, their fecal material and the pathogens wash into the water, and then that water is used to irrigate the plants. Humans, because there's many chances for humans to come into contact with the fruits and vegetables, either during production, when you spray the crops with fungicides, insecticides, if you're out there pruning, that provides a potential cross-contamination point. Most importantly, at harvest and the handling after in the packing houses, because now it's a very short time before it reaches the consumers. Water is probably the number one importance for good agricultural practices, because irrigation water can be a very common source of foodborne pathogens that contaminates the produce. The sprays. Many farmers do not think about the water quality that they're using to dilute their sprays. It's very important because they apply it directly onto the leaves of the produce. Wash. When they're harvested and they're washed before going to retail or being sold at the market. With poor water quality, it can be an entry point for pathogens. Especially in the United States and more so in Mexico, the water quality used for ice production, because when the produce is harvested, it's it's warm, it has to be cooled to extend the shelf life and ensure the quality. If poor quality water is used to make the ice melts, the pathogens contaminate the produce. Fresh fruits and vegetables pose the greatest risk for foodborne illness simply because there is no pathogen reduction step. With meat, meat is rarely consumed raw. The cooking of it actually is the pathogen reduction step. But for most of the fruits and vegetables, they want it to be consumed raw because of the texture and quality and nutrition, so it doesn't receive any decontamination step. Presently, chlorination of water is the only decontamination method for fruits and vegetables, and it's not very effective. I'll show you in subsequent slides how poor chlorine is as a decontamination method. In addition, most people don't, or most companies don't use preservatives with fruits and vegetables, and they're actually ineffective for reducing the pathogen levels, and if anything, they will just keep the pathogen levels at the present or initial contamination levels.